Good evening. Welcome to the Winchester Academy's Winter-Spring 2021 series. I am Ann Berger-Linden, and I'm the Executive Director of Winchester Academy. Thank you for tuning in. Thank you also to the City of Waupaca, and especially to our producer, Josh Werner, for providing the space and technology to bring this program into your living room or wherever you're at. Our next program will be in 1 week on Monday, February 15th. Ian Teal will present the history of and current operations of the Gerald Opera House in Waupaca. Please note that this program will have a delayed start at 6:45 p.m. Tonight's program is sponsored by Joan Wasserberg. Joan is a former trustee of Winchester Academy. Thank you, Joan. We will have a Q&A session following Bryant's presentation tonight. Questions may be submitted via the Facebook Live site or by telephone. The phone number is 715-942-9917. Again, 715-942-9917. And we will announce this number again at the conclusion of the presentation when we open up for questions. Our speaker tonight, Bryant Esch, has over 30 years of experience in environmental engineering, environmental health and safety, and coordination of environmental compliance and sustainability activities, most of those years with Waupaca Foundry. Bryant received his BS in Water Resources from UW-Stevens Point and holds many specialty certificates related to his work. Welcome, Bryant.
Well, thank you, and as Ann had mentioned, my name is Bryant Esch, Director of Environmental Engineering at Waupaca Foundry. And for the next approximate hour, or just short of an hour, we're going to talk about building the Green Foundry and some of the sustainability initiatives that are occurring at our facilities. And what I'd like to do is spend a little bit of time and speak to exactly who is Waupaca Foundry and what does Waupaca Foundry do, and maybe, well, we will give a description of the process, so what happens inside those walls that are local here. Then we'll move into some of the environmental and sustainability type things that we're working on and some challenges moving into the future and some elaboration on some great projects that have happened here locally. So we'll dive right into it. So Waupaca Foundry, as we know it here in the Waupaca area, is just one part of a larger organization that's throughout the United States. And we have several facilities. Of course, our home turf is in the state of Wisconsin, which we're very proud of, and the original facilities are in Waupaca. And of course, we have the Plant 1 facility closer to the downtown, and that's Plant 1. And then we have Plant 2-3, that's east of town. And up in Marinette, Wisconsin, we have what we call our Plant 4 facility. And we continue on to 5 and 6, which are in Indiana and Tennessee, respectively. And we also have a machining facility, which we'll talk a little bit about what goes on at one of those at, in Effingham, Illinois. And also of interest, but not on the slide that we're looking at right now. It's kind of hidden behind our Marinette facility, but we also have an ironwood facility, which is a cleaning grinding facility that supports our Plant 1 facility here in Waupaca. So what does the foundry do? Well, if I could probably take the simplest sentence I could describe to somebody, it's we take scrap metal that other people don't want and we turn it into something new. And we're doing that to the tune of 10,000 or more tons per day amongst all of our facilities. And if you kind of wonder, 10,000 tons, that's obviously a lot of material. That is approximately the weight of the Eiffel Tower. So your very own foundry here in Waupaca, as well as the other facilities that we work with, we're basically converting an Eiffel Tower every day into something new for market. And I think that one thing that's really interesting is if you look at the kinds of things that are manufactured at Waupaca. And here's an example of what we refer to as a light vehicle market. So there is really a plethora of different parts that are made for all different makes and models of cars. So if you're thinking that because Waupaca Foundry is based in the United States, that we only make things for American type companies like Ford or GM or something like that, that would be incorrect. We actually do parts for just about every vehicle manufacturer that you can name. And it doesn't matter whether it's import or made locally and all that. So as you've heard, I'm sure over the years that the vehicle market has become very globally integrated. So we're a big part of the cog of the wheel there with what goes on. So what you see there is some examples of just typical light vehicle parts that are made throughout the vehicle. And then moving along to commercial vehicle parts. So when we say something is a commercial vehicle, think of things that move materials. So these could be delivery trucks, 18-wheelers, things of that nature. There's different classes of those types of vehicles. We make a wide variety of parts for those as well. So you can see some of the different parts that are there that we do. And then we move into the sector, that's the off-highway market. And there's a lot of fun things in this category. So you tend to see a lot of the agricultural work. So a lot of different brands, including John Deere is a customer of ours. We do a lot of that ag type equipment. We do things for companies like Caterpillar on the construction side. And you also see a picture of a skid steer there, which are pretty common around our area here. And we make parts for those as well. So lots of different parts for that industry. And then when you go into the industrial market, that is where you have a lot of different industrial type equipment and housings and things that make other things go. And so motor housings are a big part of what we do. And you see there forklift and a lot of other parts. So there's really more parts there that we could fit even on a number of these slides. One thing that is kind of interesting about Waupaca Foundry is you will see foundries out there that basically specialize in making a single part or a series of parts, maybe for their own company. So as an example, I mentioned GM earlier, they may have their own foundry that just makes parts for GM products. We're different than that. At Waupaca, what we do is we're actually what they call a job shop. So if somebody has parts that they want to have made in high volume, they come to us and we work with them to basically manufacture that part on a jobbing basis. So we have thousands of parts that are part of our repertoire and of course hundreds of customers. So with Waupaca Foundry, it's really interesting that you see that big variety. One thing here that you'll see is there's a lot more things we could put on this slide as well, but just examples of things that are really obvious that maybe you would see around your household. So we do cast iron pans for a number of different companies. Right now with what's been going on with a lot of the demand, we do a lot of fitness type equipment now. You see like a kettlebell example there. And also we do, there's some kitchen fixtures and things of that nature. You can see that's a sink casting there, like a typical double basin type sink. And then all the way on the right, that's what they call tactile paving. So if you've ever been walking along and you see on a street corner, just before you get to the active part of the street, there might be some metal plate that's put into the street edge. And the idea there is for visually impaired folks that gives a warning that you're about to go into a danger zone because it's got little bumps on it. You can tell where you're going. So that is something that has a fair amount of demand, and we make those too. So I think the important takeaway from these last few slides is keep in mind that because of the vast variety of what we do, is a virtual certainty that everybody listening to this presentation right now owns something from Waupaca Foundry. And you may not know it because it might be inside something else. And that's one thing that was always kind of interesting is if somebody owns an iPhone, they know it was made by Apple because it says it right on there. But in the case of Waupaca Foundry, you might own a lot of your stuff, but you don't know because it's inside your vehicle, inside a lawn and garden piece of equipment or any of these other items that are out there. So to keep that in mind, I think that's pretty impressive for our little area of Waupaca County that we've had such a big effect on the world, and we really have reached out with so many different products that a lot of people around the world recognize, and we're an integral part of putting that all together. So when we make castings, how does that actually all happen now that we've looked at some of the things that are made? So when you look at our production process, I mentioned earlier that we are melting a vast weight of iron. And basically that can be done in a number of different ways. So when you talk a foundry, there's two very typical melting types that occur at different facilities. The one type is what I think a lot of people think of would be an electric furnace. So what you basically do is you have something like an electric induction furnace, and that device is, of course, powered by electric. And you put your iron in there, and you apply the electrical power to the induction coils within the furnace, and it creates enough energy that it gets that metal to get really hot and start to melt. And then it could either be typically as a batch process, you start to draw that metal off, and then you use it for the later parts of your process. So in our company, we do use electric furnaces. We don't have any in Waupaca, not for melting iron. What we do use is the second type of technology, and that is called cupola melting. And cupola, the easiest way to think of that is it is basically an approximate 80-foot tall silo that you take your scrap metal and your different reagents that you're going to put in to make your cast iron, and that goes in the top of the cupola. And then at the bottom of the cupola is a molten zone. So almost think like a blacksmith forge where you're kind of blasting oxygen and you have a lot of that heat and energy going on. That's the molten zone at the bottom of the cupola. And as you melt iron, that iron is drawn off the bottom through basically out a runner to go to the next step of the process, and then the stack of metal that's up above it kind of moves down a notch, and then you keep adding to the top. So the advantage of a process like that is it's a continuous process. If you are interested in melting a lot of iron very efficiently, and then a cupola is a really good way to go. In the case of the kinds of cupolas that Waupaca Foundry operates, I call them recuperative cupolas. And basically, those are designed that you take the energy that you're using, some of that can come off as like a waste heat. But before that happens, you're taking some of that waste heat and you're returning it to the process to maintain that temperature to melt the iron. And you do get some great benefits on energy from doing that. And another benefit of that as well is when you use an electric furnace, we actually would have to get the power from the power company. And there is a loss of what they call a transmissivity loss that occurs when you have that power that comes from the power plant to the point that it's going to get used, and it's pretty significant. In the case of a cupola melt, you have all your energy and power that's going on right there. You don't have that loss that's occurring. So in the cupola, we take, as I mentioned earlier, that cast or the scrap steels and irons. They go in the top of the cupola, and with them we add what's called coke. So the easiest way to think of coke, it's basically our fuel, is it's kind of like a supercharged coal. And it kind of looks like a charcoal, and it's processed at another facility and turned into foundry coke. It starts out as coal. And then that is actually used to go with the iron. It becomes the energy force to melt the iron into a molten iron. And if you think of it, the energy that's needed to take, especially on a day like today, out in our charge yard, that iron is 5 degrees. We have to apply enough energy to all that weight of iron to basically get it to melt, which is upwards of 2,500 or 2,700 degrees. The pure physics of having to do that is just really incredible. And we're going to talk about that a little bit later as well. So we take that, and then the coke is not just the fuel to do this, but it's also a carbon source. So one thing that makes cast iron is the fact that there is some additional carbon in there, and we use coke as our carbon source. And we also add other agents in there. So depending on what the customer needs, we might add a ferrosilicon or a number of different alloying agents to basically make the iron to the specification that we need. And generally at Waupaca Foundry, we are making gray iron or ductile iron. Here in the town of Waupaca, we're doing strictly gray. And then we have other facilities that do ductile. And you might ask, well, what's the difference between the two? The ductile iron, of course, has more of a, like it sounds, is more ductile, has better damping capability. And that is actually a better material for things like brake calipers and parts of that nature. So it really comes down to the end use of the product, to what kind of iron type that you're going to use. So that is the melting process. We pull that molten iron out of the cupola, and then it goes into a holding furnace. And don't get that confused with the furnaces that I mentioned earlier, which melt. So we do have furnaces on site here that do run on electric, And those are actually designed to take the molten iron from the cupola and keep it molten and have it be prepared and ready to go so we can go off to the next step. Well, what is that next step? Well, the next step is we will actually take that molten iron and we have to actually have a way of getting it from the melting area to the molding area, where some fun things happen over there. And as you hear me describing all this, you might be getting the idea that there's a lot of different parts about the foundry, and that's absolutely true. Matter of fact, a lot of times you'll go in a foundry, you'll look at it, it's almost like having 3 or 4 different types of factories all under one roof. And that's what we have going here to make all this kind of sync together and have the part go out the back door. So the molding area in a lot of ways is the center of the plant where all these different parts come together. And so we're going to take that iron and put it in a hot metal carrier, which basically is I guess we'll call it a crucible or a ladle. And that ladle has to be, of course, it's made out of a metal or something like that, but it can't just be metal and then pour molten material in it because it would melt itself. So in the foundry, anywhere you see where we handle molten material, you're going to have a vessel or a ladle or some device like that that's actually lined with a refractory. And the refractory is almost like, when you see it being put in, it almost looks like somebody laying concrete in there, and it's just meant to be kind of like in a wood boiler or somebody's stove at home. There's refractory brick in there in many cases to protect the metal of the stove so you don't have it melt. We have the same thing. So the hot metal carrier will take that iron over to the molding area. And there at the molding area, we are using a technology that they came up with about 2,000 years ago. And what they learned a long time ago is if you actually have the power to melt a metal, whether it's brass or whatever it is back in the old days, and you wanted to make it into a mold or into a shape, the logical thing that we think of is that we're going to pour that material into some kind of mold made of wood or whatever, and then we'll allow that metal to cool. And then when it's cool, we can kind of like knock it out and you have that thing of your shape. Fortunately, when you think about cast iron and that high temperature, 2,700 degrees Fahrenheit, what do we have that we could pour the molten iron into? And the question, or the answer is you don't actually have a whole lot of choice. Other metal won't work, of course wood won't work, plastic won't work, all that stuff. You kind of get to the point where you have to find something with a higher melting point than iron. That something is sand. So for all those who are somewhat familiar with Waupaca Foundry and you know that we use sand, that is why, because that is something they discovered in the Middle East, again, thousands of years ago, that actually worked for molding. So we have a part of our plant where we take sand, and if you were to look at the virgin sand, it pretty much looks like regular virgin sand like we would see in central Wisconsin. And we add some things to that so it can do the job that we need. What's so special about the sand around here is that Wisconsin is actually known for having very good foundry sand. And I believe that is also, well, it is part of the reason why when fracking, if anybody's heard of that industry, when fracking became a big thing and had a boom, all of a sudden Wisconsin was seeing a lot of pressure from that because we had that kind of sand that is adequately sized and it's a nice spherical sand grain and was perfect for their industry. Well, foundries have been using sand from Wisconsin for a very long time, and that's one reason why you see so many foundries in the state of Wisconsin, because it was just perfect conditions for that kind of business. So we take that sand and we add in what we call a sea coal, and that is a high-grade powdered coal that comes from out west, and that is what makes the foundry material black, or the sand black. And then we also add what we call sodium bentonite, which is, the fancy word for that is just clay. And then if you take that mixture of the clay and the sea coal and the sand, and you add just the right amount of moisture, you can actually take that material and you can form shapes out of it. So if you want to make sand castles out of this material, it would be just perfect for that. And we're taking advantage of those properties. And at the molding area, they're actually making a mold of a block of sand. And they take that block, there's a machine that historically was called a DISA, but now we call these vertical molding machines. And that machine will take a lump of sand that we've prepared, form it into a block, We'll have a pattern that'll put a shape in it of what we want to make. And then the second half of the block comes, and the other half of the shape will be made there. And then those two blocks will be put together, and we'll actually leave a pour area in the middle. So you can actually fill the top in with iron and fill up the mold that you put together. That's basically the two halves are squeezed together, and your void space or your mold is on the inside of that. And so we do that, and you can do any shape that you want. And that's what gives us a lot of our flexibility, that on a vertical molding machine, you can make a lot of different shapes depending on the size of your machine. So if you look at the traditional way of doing that, they had what they called horizontal molding. So the most obvious way to pour a mold of something is to make your mold that you want and then lay it flat. And then you pour your iron into it so that it just kind of lays there, and then you can let it cool. The problem with that is when you have all these molds laying on your floor and you're trying to actually produce castings, it can be a little bit cumbersome because it takes up a lot of floor space and tends to be a little bit slower. If you switch to vertical molding, which we did back in the 1970s, which was a very new and unique thing in the US for a company to do that, it takes those horizontal molds and it actually stands them on end, and that's where you get the vertical part. And when you stand them on end, it's almost like books on a bookshelf. You can store all your books laying over the floor, or you can put them on a bookshelf and they're all tidied up and in a line. Same thing going on in our case. So we can shuffle them along and get very high molding rates in smaller area with the vertical molding. And I think it's safe to say that historically vertical molding has really been a bread and butter process for Waupaca Foundry. So one thing that is important to think about too is there's a lot of parts that are made exactly that way, but sometimes you have something that has to have a hollow space in the middle. So just a simple example. So in the process I described earlier, if we want to make a bowling ball out of cast iron, which I don't know why you'd want a cast iron bowling ball, but if we had to make one, we would probably take the first part of the mold would come through and it'd have like the semicircle half of the bowling ball. That would shuffle in, and then we would do the other half of the mold, which would have the other half of the bowling ball. We'd squeeze the two halves together, and down inside that mold, you'd have your round circle, and we would pour the iron in the top. If you wanted to make a hollow bowling ball, now you're talking that you need a different technology to do that, and that is actually called core making technology. So we take a sand that's very similar to the sand I described earlier, and that sand is run through our core room, which is another part of our process, which exists strictly to make the void spaces in castings. And that core room uses a couple different resin technologies that are commonly used. But one example would be if you ever gone to the hardware store and bought a can of the Great Stuff foam, which would be pretty handy on a day like today where it's like 5 degrees out, to insulate around your doors and your windows. We use a very similar formulation as that. And we put about 1 to 1.5% of that kind of resin in some sand in a core machine. And we make the shape of the void that we want. And when we're all done, we actually, in the core room area, we have a block of sand that's the shape of what we want that you can actually hold and move around. That gets made ahead of time and then moved to the molding area when it's needed. And that material gets placed inside the mold before we close the two mold halves together. And then when it shuffles along, it gets to the point where it actually gets poured. So we have a ladle right above the molding line that, if you look real close in the pictures, you should be able to see it on the slide where there's one picture of some iron getting basically administered to the top of the mold. And then that would go into the mold, fill it up, but where the core is, the iron would go all around that. And what we do is that core is solid until it's exposed to heat for some period of time. And then later, that sand will break down and we'll leave a spot somewhere in the pattern or in the mold so that that sand will have a way to get out, that core on the inside. It'll break down, it'll flow like sand out an hourglass. And then when it pops out the other side of the line, we're gonna have actually our casting with that void space on the inside that's needed. So those are the two different kinds of pouring that's going on, the non-core jobs and jobs with cores. And one thing that has been a lot of technology has really moved with the core technology, and there's just amazing things that you can make now via casting. So there are a lot of parts out there that maybe historically were made by making multiple parts and then maybe welding them together or forging them in some way. But now with casting, if you can be pretty clever about how you use your technology, you can make a part via a mold that you could never make before. And the advantage is a casting all made as one piece has such extremely better strength than when you make multiple pieces and try to weld them together. Because that's typically where things break later in use, is where things are welded. So that iron that we pour into the molds, again, remember they're kind of like books on a bookshelf. They're all waiting and moving down the line, and it takes about an hour approximately for those to cool. And they cool to the point where they're not liquid anymore. So as soon as they are cool, we can go to a fancy process with a fancy name, which we call the shakeout. And what happens is that sand and iron that's now hardened, might still be glowing red hot, but it's hardened, goes into the shakeout, and you got it. The shakeout just shakes that material, and that material is, the sand is basically separated from the iron, and we send the sand off for reuse, and then the iron is ready for the next process. One thing that's important to note is that when we pour those molds, if anybody ever made models when they were a kid of ships and airplanes and that kind of thing, remember that you have your parts and you have to break them off the tabs, and when you're done with your model, you still have all the extra tabs laying around that normally would get disposed of. We have something similar. We call them gates and sprues. So when we pour the iron, there's actually little channels and spots where we let the iron go to where it needed to go in the right kind of way. And those gates and sprues are completely good iron. They're just not part of the part. And so that part of the molding process, we actually have to recover that after the shakeout and return that to the melting area and melt it again. That is one drag of having a foundry, is because not quite half, but in some cases nearly half of the iron that you are melting, you have to melt again. So I'm going to talk a little bit about that later, how we try to improve on that, and that's a big environmental issue for us. And then after that, we cool the casting, and typically that just goes into what we call a cast cooler. We blow air over it, and we get to the point where it's, when it comes out of there, it's basically cool enough to handle, and then it's ready to go off to our cleaning and finishing area where they will, if there's any like little rough tabs where the gating or the sprues came off, they'll grind that down. It will get shot blast, and it will look much better when we're done with it than it did when it came right out of the process. Of course, in the cleaning and grinding area, that's also a big QA, QC area where we check the quality of the part and make sure that it's up to par for what the customer wants. And in many cases, when we're done with it, it may go off to another facility that's that's commissioned by our customer or ourselves to go to the next part of the process. So you could have a part that needs additional finishing or needs bolt holes tapped in there or anything like that. It's not uncommon, especially on like automotive stuff and things of that nature, where it goes to another facility before it goes to the end user, be it Toyota or whoever it is. So that is the process. I don't think I missed anything, so we'll move on here. So when it comes to foundries, I think sustainability is a word that a lot of us have heard for a number of years now. Of course, the importance of it is growing and growing. And I think that foundries in general, especially our kind of foundry, has a really good argument that what we're doing is very sustainable, because we're taking such a large amount of material that would otherwise be disposed of, and we're turning it into something new. And if you compare what we're doing to actually having to go out there and like remine new ore to make more metal, we are doing what we're doing on the recycling side is much more environmental of a process. So that's all good, but when it really comes down to it, the average modern foundry can't just rely on the nature of our business to really have that be like all of our points that we're doing a good thing. There's other things we have to do above and beyond that. So we're going to talk about some of those. So Waupaca Foundry is proud that for a lot of years, and we've worked on a lot of different projects and really tried to optimize our process and done things to really understand our impact on the world and make improvements on them. So here's some examples of things that we've achieved in the relatively recent past. So, I had mentioned all the metal that we use. That 94% of all of our metal feedstock that's going into our process is actually this recycled scrap stuff that we talked about earlier. So it's obviously a very high number. We get hit up by customers all the time where they're like making parts for something that's trying to get LEED certification, or is something that has like a recyclable content minimum kind of thing. They're always contacting us and looking for that number, and they love it when they see that because that's a very high number for a product to have recycled content. We're going to talk a little bit about energy later, but I believe that energy use and consumption is our biggest impact on the world. So we're working on a project now to decrease our energy intensity by 25%, and we are getting pretty close. So we'll talk about that. And what goes along with this, we don't really have a lot of carbon emissions that occur from any like weird process or anything like that. A lot of our impact in that area is just actually from the consumption of energy. So all the energy use reduction things that we've done has also reduced our carbon footprint. And so right up to now, we've reduced our carbon emissions by 3.1 million metric tons. And as a comparison, that would be like 70 standard windmills like we see on the side of the road, or wind turbines running constantly all the time through the year. That's the amount of energy that we're saving. And also we're pretty proud of some projects that we've done here originally in Waupaca on heat recovery. So we'll talk about that a little bit. But when we do one of those projects, that could be an instant 20% benefit to that plant on their heating needs for sure. And as we talked about Foundry Sand, we actually are using Foundry Sand in our process. But at some point, there's a reason that we have to move it on, and we'll talk about that too. And right now, 80% of all the foundry byproducts that we are generating are actually getting reused off-site. And that took a lot of years to get to that point. And then also on water demand, so foundries are very water intensive. We do one of our closed loop cooling systems, we can knock that down by 90% right on that system. So all these things put together, we've gotten into a lot of voluntary programs. There's really none of this that's required by anybody, but we have gotten in with the Department of Energy on a couple different programs. And then you notice on that slide there on the bottom, there's a reference to the green tier, which is actually a Wisconsin program. It's a great program that's administered by the DNR. And basically, it's a collaborative effort of the regulatory agency and industry and so on to work together to do voluntary benefits to the environment and to track and spread that knowledge to other industries that can basically learn from it. So we're going to spend a little bit of time on this slide because I think this is some of the nuts and bolts here. So as I mentioned earlier, energy, see on the upper left-hand corner there, that again is our biggest impact on the world. We are using like the energy to melt that amount of iron and just overcome that physics is just tremendous. So a lot of us are probably familiar with a little utility called Wisconsin Public Service, which I think a lot of us get our bills from. We are actually their largest customer at Waupaca Foundry. And you think they are not a small utility. And you look in northeast Wisconsin, there's certainly a lot of other industries around, such as paper mills and all that, but we're still their biggest customer. And why is that? Well, a lot of it is just, again, the type of industry that we are and what you're having to do to melt iron to that point, and then all the equipment that goes along with that. So we had always known, of course, energy is a pretty significant expense for us. And we are in an environment where, if you want to start a business, I would not recommend that you start a foundry in your garage. It is pretty competitive out there in the world. There's foundries are a base part of industry. They're needed for so many things that we have around us. But any country that manufactures things tends to have foundries. So when you look at countries like China and Brazil and India and so on, very heavy foundry countries. And how do you compete with that? Because again, not everybody is playing on the same set of rules as we go from country to country. So certainly one way that in the U.S. American foundries can have an advantage over their worldwide competition is in the area of energy. If we can be leaner and meaner than the other folks and do it more efficiently, not only does that help the environment, but it helps sustaining the American foundry industry. So we did a lot of projects going back, but I would say about 2004 that we really had that tremendous recognition of this, and we basically started doing projects. So as an example, a lot of the lighting that even in this room here that we see, lighting has gotten so much better and there's so many more options than there were even 10, 15 years ago. And with all the LEDs that we see now, so there are fixtures out there that can be used even in a commercial setting that only use 25% of the energy of the lighting that was available years ago. So we embarked on a pretty major plan of lighting retrofits for our facilities and putting that kind of hardware in. Also motors. If you visit one of our facilities, you're going to see that there are a lot of motors doing work, moving things around and all that. And when you go out to buy a motor, you can get a regular old motor, which costs X amount of dollars, or you can buy a premium high efficiency motor, which is, of course, a more expensive motor than the regular one, but it actually uses a little bit less electricity when you use it. And really, the cost of owning a motor over the life of the motor is not buying the motor, it's all the electric that you put through it. So many years ago, we decided that it was worth spending the extra money to save on the electricity over time. So right now, we mandate all new motors has to be premium high efficiency motors. We also did a lot of air compressor improvements. Air compressors are innately, when you compress air, it's very energy inefficient. So anything we can do to reduce our dependence on compressing air only helps. So we did a lot of those kinds of things. And then one thing that was actually kind of fun is waste heat recovery. So many years ago, if you drove by one of our facilities in the winter, you might look along our roof line and you might notice some heat coming off the roof line. And that was the waste heat from our cupola melting systems, the part that we no longer needed. And for example, in the case of Plant 2-3 on the east side of town, their waste heat off that facility is 80 million BTUs. So how much is that? I mean, that's like 3,000, 3,200 wood stoves like you would normally see in somebody's house, that much extra heat available. What we did is we started doing projects where we would take that waste heat and use it to preheat the air that would come into our building. So in the winter, we could actually heat our building with our waste heat instead of having to consume natural gas. So we did that first as a pilot at our Plant 2-3 facility. Then after that, Plant 1 put in a great automated system on their side. And we got a lot of recognition for that technology because it is relatively simple and it could be applied across a lot of other industries as well. So we won some awards for that and our team is really proud of those. So we continued kind of doing projects and we got to about 2009. And what happened then was the U.S. Department of Energy at that time was challenged by the president. And the challenge was, okay, Department of Energy, what are you doing to ensure that our organizations in the United States are being as energy efficient as possible? And the answer was a program called the Save Energy Now Leader Program. And what the Department of Energy did is they reached out to industry and organizations in general. And it wouldn't matter if you were a foundry or UW Wisconsin or the Wild Rose Fish Hatchery, any organization out there. They said, okay, everybody, who would like to volunteer to save 25% of your energy intensity over the next 10 years? And when the volunteers came back in 2010, they had 32 volunteering organizations that signed up on it, which is a little disappointing in the fact that if you think about all the organizations in the 50 United States, there's probably thousands that could have done it, but only 32 signed on. What I think is really neat is that of the 32, 9 of them are from Wisconsin. So of all the states, we are nearly a third of all of it. And I really think that's because we have in Wisconsin what is the Focus on Energy program. And that program has really worked with homes and industry for a lot of years to apply rebates and do good energy practices. And I think that really kind of had that awareness that helped Wisconsin. But then also out of the 9, 3 of them were foundries. So that tells me that what we talked about earlier about foundries kind of thinking about their competitive stance and all that, there's other foundries out there that are all thinking the same thing. So the 3 foundries that signed on to that was Neenah Foundry, Manitowoc Gray Iron, and Waupaca Foundry. So we have worked under that program, which is now called, they changed the name, it's the same program, now called Better Plants. And we are in year 10 of the 10-year program. And I'm happy to say that we are at approximately 23% savings right now. And but I'll tell you, it's getting harder because when you start off, you do all the easy stuff. But now we're getting along and like all the low-hanging fruit has been done as far as energy type improvements. Now we're really working on the very hard stuff of what it takes to get that last little bit out. So we have just a little bit left to go on that. And we're doing some interesting technologies. One is called dehumidification. We're in our cupola that I described earlier. We're melting the iron. We're actually drying the air before it gets in there. And if you can remove water from the air, actually the combustion is much more efficient. So imagine trying to have a campfire with wet wood versus dry wood. And any way you can get the water out only helps your efficiency. So we're doing a big project right now on that. And again, we're optimistic that we are going to be really close to meeting our goal. So that's energy there. Going on to air pollution control and state-of-the-art technologies. So in that area, if you have any kind of business, doesn't matter if you're a printing business or you're gonna paint cars, like automotive painting or whatever it is, if you have anything that where you have emissions that come off of your process, if you're over a certain threshold, you can't just build your business and do what you need to do. You actually need to put in an application to the DNR, basically asking permission to create that equipment and to do your business. So of course, Foundry is no exception to that. So if we're large enough that pretty much anything we do in our facilities is something that requires an air permit. So we have a lot of interaction with the DNR and the EPA over our processes and what goes on there. What's kind of neat is in EPA, they have something that they call Best Achievable Control Technology. And that's a part of the Clean Air Act. And basically what it says is that, okay, if you're going to have any kind of operation, again, it could be any industry, if you're going to have any kind of operation and you're looking to the state or the EPA to get a permit for something, you have to put pollution control equipment in that's at least as good or better than what anybody else has ever done before. So us here in Wisconsin, if we find out that in, say, Georgia, there was a foundry down there that put in some fancy piece of equipment that does a really excellent job at removing any kind of dust from the air or something of that nature, then we would be forced to put in something, that same thing that they put in or something better. So what we're very proud of is that when you look at there's a backed clearinghouse out there where they have every industry and what's considered to be the best pollution control equipment. And when you look in the foundry section for every type of foundry equipment, molding machines, the cleaning, grinding we talked about earlier, cupolas, all that fun stuff, core machines, all that, every one of them with the best technology, it's all listed to be Waupaca Foundry, Waupaca Foundry, Waupaca Foundry. Sometimes you see ThyssenKrupp Waupaca, which is of course our old name, all the way down the list. So we're really challenging the other foundries to keep up with us. And I think there's a couple reasons for that. One is our management has been very proactive on these kinds of things over the years. And also we do a lot of permitting. You know, we're pretty big and we have a lot of customers. We're constantly changing things to keep our customers happy. And because of that, we're constantly working with DNR and always kind of at the till and being checked on what we're doing. So we're proud of that, and our goal is to continue having that status with EPA and DNR. Next topic we talked about a little bit, which was Foundry Sand. So that whole process I described, we're using Foundry Sand, and we get to the point where a lot of people think we have bad sand that we need to get rid of, and that's not really the case. We get to the point where we just have too much sand. So remember earlier when I was mentioning that we have the molding process, and then when we use sand, we can actually send it to the sand prep area and like reconstitute it and use it again. And 1 grain of sand in our plant gets used many, many times over. But what happens is those cores, and we have what they call a positive system. So when you put all those cores in all day long for those parts that you're making, that's extra sand that you put in. And at the end of the day, our silos are just too full with sand. So we actually have sand that a lot of foundries would die to have, but we just have too much of it and we have to get rid of it. That's the big reason why a lot of that material goes out. And we also have what's called slag. So when you melt iron, you get a separate layer that comes out. It's kind of like the impurities from melting the iron. And that's actually slag, and it's kind of a black glassy material, very highly prized in like the aggregate industries, and there's a lot of reuse in cement and all that. But those are the 2 big byproducts that we have. So for many years, north of Waupaca, we owned and operated our own landfill, and we still do. And what was amazing was back in the day, we had about 400 truckloads a week of material that would leave from our Waupaca plants and go to the landfill. And what became to be realized back in the 1980s, late 1980s, was that EPA and DNR were like, why is a facility like Waupaca Foundry, why are they having to put sand in a landfill? Because there's nothing toxic or wrong with it. It actually would be very useful for like construction type purposes. So in the late 80s, there started to be some pilot projects where they started using Foundry Sand in Wisconsin for different kinds of road constructions and things of that nature. And Waupaca Foundry was a big player in that. And we did projects via like on a case-specific basis, one at a time, as they were kind of working on this program. And it got to the point that it was so successful that in the mid-1990s, they actually passed in Wisconsin a beneficial reuse rule. And that rule is great because it's very strict and there's a lot of testing and things you need to do, but it basically gives you the recipe of here's what you need to do to validate that you have marketable material that can be used on all kinds of projects. And we do that, and typically our material tests out on the very, call it the happy side of the scale. So that allows us to do lots of different kinds of projects, agricultural and commercial and road construction and all that. And I'll have some examples of some of those later. But so that has brought us to the point where we are today, where really at any given time, we have a number of projects going on locally that are beneficial reuse related. And as I mentioned earlier, 80% of everything that we generate is going to a project and not going to the landfill anymore. So the landfill has become a much more boring place than it used to be, and that's okay. So we're going to talk about the best thing that we can do with Foundry Sand, even better than using it off-site for reuse, is to use it again in the foundry as much as we can. I'm going to show you a project that we did shortly in a couple slides here of something we did to kind of try to take that to the next level. And then the last little window here on this slide is water. So in the case of our facilities, we foundries in general used a lot of water, and they used it for a couple different purposes. And water was used either for wastewater treatment purposes and scrubbing of the gases from the cupola, and also for machine cooling. So late in the 1990s, we went to some state-of-the-art pollution control technology that is all based on dry technology or baghouses. So all that use of water that we needed for a wet scrubber is gone as of the late 1990s. That was great. And then we have a lot of the machine cooling that we were doing, which was, again, about 1 million gallons of water a day, which for a town the size of Waupaca is a pretty significant amount of the water use. That was getting pulled from the city. It would go through cooling coils to cool machines. It wouldn't become dirty or anything like that, but when it came out, it would be slightly warmer than what it was. Then that would get discharged to the Waupaca River. That is all gone right now, because what we did was we took that once through use of water, and we put in closed loop cooling systems and air cooling systems, and removed the need to have that water continually replaced. We just use the same water over and over again, or use air instead. And every plant where we've done that, we have significant improvements in water use. So our goal was to, our 10-year goal, which is ending this year, was to reduce our water use by 80%, and right now we're at approximately 67%. So we're really close, and we have some more projects going on just to try to squeeze that last bit out of that. So right there is 4 areas that I think are very critical to just foundry sustainability performance. And these are the kinds of things that you need to do on top of just saying you're sustainable because you're recycling iron. So here's some examples of some things that have gone on locally that maybe some of you are aware of here. So here's one project where out at Eastgate Estates and the Eco Park, where there was an area that was conceived of that could have a different use, and ultimately the foundry provided Foundry Sand for use in this project. One thing that I want you to think of as we go through these few slides on some specific projects, that we have some really smart people at the foundry that have done some amazing things over the years, and I know I'm biased, but when they say that they're world class, I can just tell you, at least from my point of view, that that's certainly the case. There's some really neat things that our staff has done. But on top of that, I look around our communities, and some of the things that we've done have actually been ideas from within the community. And having that interaction with our community and our specialist has really made a lot of neat projects happen. And this was one of them, where this was a collaborative effort. It wasn't just Waupaca Foundry doing the project. It was, elements of the local populace and the city of Waupaca and all that worked together to make it happen. That's why these projects are so successful. So in the case of this one, it ended up with nearly 30,000 yards of material used that otherwise you would have had to go mine from somewhere else to get it. And this is certainly a better way to have construction material versus mining elsewhere. Another one that I got to enjoy not too long ago is Swan Park and the sledding hill. So another project that I think would not have happened without some different parties within our community here that really thought this was something that was had a real potential for adding to the value of Swan Park and being just kind of a neat resource to have around here. So that one was 200,000 tons of Foundry Sand. Took a number of years. And this one actually has gotten a lot of national notice. So if you look on the internet about Swan Park and Waupaca and Foundry Sand and all that, you're going to see that there's been some recognition out there what we did here, and there's other places trying to figure out maybe we should do something like that as well. So, and another Foundry Sand use is for agricultural projects. I had mentioned earlier that Foundry Sand has that sodium bentonite in it, and basically what that means is if you take Foundry Sand and you moisturize it to the right amount with that powdered clay in there, if you roll it and compact it, it actually makes what they call a low permeability surface. Or the easy way to put that is water doesn't get through it very easy. So there are all kinds of projects that happen out there where they want a low permeability construction material, and a lot of times they'll mine clay. What we've done is we've taken Foundry Sand and worked with the DNR. They were our collaborative partner, and NRCS, you can see on the slide. And we've done some studies, and we have demonstrated that Foundry Sand, when you handle it in a certain way and then you lay it down as an underlayment, it's a great thing to put under like a manure pit because it's like an extra level of protection that basically acts as the bathtub, and or even for like landfill construction, because landfills are designed to contain things and not let liquids through. You can take Foundry Sand and do that. So we do market and use our Foundry Sand for that purpose as well. And if you kind of look out there in that area, you're going to see Waupaca Foundry's name come up in a number of things. But this is a local manure pit that was done with Foundry Sand. One of my favorite types of projects are mine reclamations. And in Wisconsin, as you're probably aware, we have a lot of legacy sand and gravel mines and pits. And some of these are from way back when. And nowadays, well, it used to be that somebody might have a mine, they'd use it, and if they decided that it wasn't active or they weren't doing anything with it, it might sit for some period of time. Nowadays, there's some laws out there that basically say that, hey, you don't want a big blister on the landscape. You really have to do something to reduce the slopes, make it serviceable land again, and not be an eyesore. So we have done quite a few of these in, I believe, 3 different states. And I'll tell you, if there's ever a project that's appreciated by neighbors of mines, and it's just a great use of the material, is in this. So we will actually put material in, reduce slopes, and try to make it usable land again, whether it's for cropping or whatever. So mine reclamation, this is the local one here too, obviously. I had mentioned our heat recovery system that we did at Plant 1 for energy savings. And that is a picture of what that looks like on the roof. So if you're coming off the end of Main Street and just kind of going by the foundry, if you look at the roof that's closest to like the Waupaca glass area there, you can see the top of those heat exchangers there, and that's part of that heat recovery system. So that is the technology that we've really pushed in, and we're working to expand that across our facilities, those facilities that are in the cold areas. But just the carbon footprint reduction on just reusing your own waste heat is tremendous. And this project was one of the main reasons why the state of Wisconsin in the last couple of years has actually designated waste heat as a renewable resource. So when you actually use waste heat in this way, it's got a whole new designation in the state, similar to solar and wind and all that. So we've talked a lot about reusing sand on offsite projects, and again, the best thing we can do with sand is use it for the foundry. So when we have sand, the best way to bring our sand back into the plant is as a core. Because as you remember, we're putting all these cores into our system. And typically, we can't do that with our regular sand that we're molding with because it has that clay in there. And if you try to put it all together and put the resin in it, it would just kind of fall apart on you. So there is a technology that has been used in Europe. But we decided to try this technology for the purpose of recycling our foundry sand with the clay in it, which is not real typical to do. A pilot unit was put in our Plant 2-3 facility on the east side of town. And this unit takes 2.5 tons of sand an hour, puts it through, and it first separates it so we get the grain size that we want. And then it cooks it up to about 1,300 or 1,400 degrees. That's the thermal part of it. And it gets all that clay and everything to pop off. Then we separate it again, and you have some material that you can't use, and that goes back with the rest of our byproduct sand that would go off site. But then the stuff that you've separated out, that goes right back into our process, into the core, and it's helping to close the loop. We've had great success with this. We ended up putting in a much larger system at our Indiana plant in southern Indiana, and hoping to expand this technology. And to my knowledge, we're the only ones in the U.S. that are doing sand reclamation quite like this. And another fun project and a good example of local input is our industrial carbon capture pilot study. So what you see here is basically cyanobacteria or microalgae that is being grown in a growth cell. That's those green tubes. And what we did was we took basically emissions from our cupola, which remember we're burning coke and all that in the cupola, so there's a higher carbon dioxide coming off there, just like there is anywhere where you burn fuels. And then we took that gas coming off the cupola and we bubbled it through these growth cells. And that green that you see is actually the algae growing. And this algae, there's lots of different strains of it out there, but this algae is actually known to double its weight in 4 hours or less, so a very fast-growing algae. And the idea is the algae, then if you can grow enough of that biomass, you can actually use that to make other fuels or co-products for other industries or agricultural products. Has a lot of value out there. This has not, to my knowledge, been done on any large scale. It's a technology that's been talked about. And I'm not aware of any foundry trying this, but this was actually highly successful. We had our cupola gases supported the algae very well. We had great growth, and right now we're working on a phase 2 of this, and there's some grants that us and a partner are trying to get from the Department of Energy. And we're working on, when the bubbles come up through that growth cell, we're trying to get really good mixing. And there's a technology there to kind of help that with the mixing. That's underway right now. And so this has a lot of potential. You know, there's things we're doing now that are having a lot of benefit, but pilot studies like this is what our future is going to be. And I'm hoping that 10 years from now, you know, we'll have a really exciting project to share with everybody having to do with sequestering carbon from our process and making a viable product from it, and our carbon footprint would just drop significantly with that. My comment about the local populace and involvement and all that, this was something that we were aware of this, but one of our neighbors of the Plant 2-3 facility was instrumental in connecting us with a professor from UW-Oshkosh that was a specialist in this. So again, we value any kind of input that our neighbors have. If you ever feel kind of sheepish about giving us a call about something, don't. Please call, because we get ideas from all different places, and even if there's a couple of ones that don't pan out, there's always that one like this one that gets you started. So thank you to all who in the past have really been free-flowing with assistance and help on these kinds of things. And we're all in it together. So with that, I will conclude the PowerPoint part of the presentation.
Okay. Thank you, Bryant. This was a really, truly wonderful presentation. I want to remind our viewers that if you wanted to phone in a question for Bryant, that phone number is 715-942-9917. We have a very small studio audience. Do we have any questions from the audience? Your mic there is live.
How about generating a vortice in the bottom of the tubes so that you get what amounts to a cyclonic effect in the carbon reharvest?
You're right on it. You must have been an industrial arts instructor at one time.
Well, at one time.
So that's actually what we're working on. So there's grow cells that we're trying to have like a sculpted, it's kind of like a plexiglass material or acrylic. We're trying to do it where it's like sculpted in a certain design way, so that as the water and the air is flowing through, you get more like automatic mixing. So yep, that's exactly what we're working on.
I'll hook you up with a glass artist who might be able to help with that.
That'd be great.
Okay, here's another question. Coal or coke is not considered a clean fuel. Are you working on developing any technologies to move away from that, or is that such an essential part of the process?
That's a
you
really
can't
good
move away from
question.
it?
Yes, so coke is an industry that has its own emissions as far as coking plants that make coke. And it also is in fairly high demand now, but there's not a lot of makers that make it anymore. With coke, it actually has very unique properties that help us quite a bit. So because we're a jobbing shop and we make so many different kinds of things, the furnace or the cupola allows us to add carbon in that way versus having to add carbon in other ways. So it's kind of tough to get away from, but we have done some coke replacement type activities. So we have found carbon that comes from other sources that's not coke. And so there's some industries that have like I guess we'll call it a non-combusting carbon that we can use as a replacer. And we've done that. We're actually doing that right now as we speak and have replaced some of the coke. I think what's going to happen over time is that as we're going to have another energy reduction goal, and we're always going to hit into that wall of what do we do when we can't get rid of the coke. And I think what you're going to see in the coming years is this concept of getting involved in what they call virtual purchase power agreements, or maybe us even doing our own like solar or wind type projects for the strict purpose of offsetting the use of the coke that we're using. One possibility that you have to get away from the coke is to use an electric furnace, as I mentioned earlier, but remember, they're very inefficient. So in a lot of these environmental projects, you have that trade-off. You might get a benefit in one way, but then you're going to take a hit in another way. And in some ways, electric is that way that, sure, you're not burning the coke, but now you're relying on a power plant that's consuming something over on their end. So that's a really good, deep question, and something that's very high on our radar right now. And I do think that we're going to make some hay on that in the coming years.
I have a question here from Austin, Texas.
Oh.
They're watching online.
Awesome.
Actually from Waupaca, but right now residing in Austin. They asked, companies have moved to Waupaca to serve the foundry in the past. Do you foresee more companies in the future moving to our area to serve the foundry?
I think the short answer is most probably yes. I mean, if we look at history, what's happened, there I didn't really get into this, but we're, of course, in the industry, there's a lot of foundries in Wisconsin. It's one of the strongest foundry states. There's a lot of foundries in the U.S., I think on the order of about 2,000 foundries. But we are considered the gorilla as far as like size, and we have a lot of needs to move that much iron. So just the scrap metal that we're pulling in, it's basically almost like we're a giant sink just sucking in all the scrap metal that's available from Wisconsin and the states around us, just due to our size. And for that reason, we've seen that we've had some of these scrap suppliers and other vendors that have moved into our area. We've even had customers of ours that have come into the area just to be close to where the product is, so you can kind of eliminate that inefficiency of having to transport and move castings around, because of course they're heavy. So I do anticipate that as years go on, we are going to see other peripheral businesses and things that kind of come in because of our dominance in the marketplace.
Okay, I've got a question. A lot of the adoption of these practices is kind of experimental, or you don't really know what the results are going to be, and so it's kind of risky to fund the research and development of all of this stuff. What process is used strategically to kind of decide which direction to take or how much risk to take with some of these things? I mean, it's more a financial question than, but still there's got to be a input between the technology people and the finance people.
Yep. So what we run into is we have all kinds of projects that we're working on, and the problem is you have to prioritize. So when you have lots of different projects, you only have so many resources, or you may have some that are a lot juicier of a project than another one. So common sense says, let's work on this one we're going to get more benefit out of. So let me give an example. We have a lot of energy use reduction type projects that we work on. Some of them that are out there is considering the use of like putting in some solar panels and stuff like that. But the problem is we look at what is the big benefit and the capital investment needed. So we have a lot of projects that we could actually do that have way more environmental benefit and more economic benefit than putting in solar panels. Because we get asked that all the time, how come we don't have more solar panels? The reason is we're trying to work on the things that give us the biggest benefit first. And so we really work to prioritize those things in that way. Now, one thing that I think is kind of neat about Waupaca Foundry is that when you go to some businesses, I can't speak for all businesses, but when you go to some, they look at what the benefit is and how much it's going to cost on capital investment to do that. It's very typical if something is more than a 2-year payback, they lose interest. And in my experience, Waupaca Foundry is really willing to entertain projects with a lot longer view and a lot longer payback. So there's projects out there that we think that could be a great benefit once we get past the engineering side of it, and they might have 12, 14 years payback on them. So yeah, that question is really important because we're fighting that all the time with the different opportunities and where do we best put our, which basket is best for our eggs first to get the most out of it.
This is more of a comment than a question, but it came from our Facebook feed. A friend of ours, Kari Espenson, said, I want to share with the community that for a number of years, Bryant was a wonderful contributing member of Working Together for Waupaca County, which was committed to encouraging sustainability efforts in our area. It's so exciting to see all the neat things that have been happening since with the Foundry, including the carbon capture microalgae project he spoke of at the end of his PowerPoint.
Oh, well, thank you. So, but that's a good example of, I had mentioned how there's been a lot of partnerships that have occurred locally with a lot of our local residents, and these things have really kind of fueled a lot of these great projects that have happened, so.
And I have another comment from the phone line. Basically, it's that they appreciate the amount of cleanup that's been done, especially over at Plant 1.
Excellent. So nothing makes us happier than hearing somebody say that, hey, compared to something 20 years ago, it's so much better. We just love to hear that because sometimes we're there and we're working hard on these things, and sometimes when you're there every day, you don't see it. But then when you look backwards a little bit, you're like, wow, things have really gotten, very much, in a good place. So thank you very much for that comment.
Well, I think we're at the end of questioning, so thank you very much, Bryant.
It's my pleasure.
Have a great week. Stay
You
warm.
as well.
Okay. I think we're done.